We have been struggling for months on designing the top of the 12-rotor engine. We have started with these 28-pound chunks of metal, 3 of them, and turning those into something that can handle over 6,000 horsepower and only weigh 5 pounds. This whole video is all about basically using AI to make some of the craziest parts of an engine we've ever made. As we've put all of our resources into building this 12-rotor, we got to talk about getting air into the motor. There's a lot that has to go on. This is insanely custom, and the sheer amount of material, time, effort, and size that will make this one-off stupidly expensive, but totally worth it. So how do we get from here to there is where you have to pay to play. This right here is quite literally $1,000 of aluminum. You end up paying per pound. The metal is technically $778, but shipping, taxes, all that stuff adds in. Two of you guys out there are like, could have got it cheaper. I know that, but this is like what it takes for anybody to get metal, because if you got to hook up, you got to hook up. The main company, which is out here in Los Angeles, shows you exactly what the metal is made of. This is 6061. I asked for a 3-inch by 3.5-inch piece. We're basically gonna do all of the air fuel mixture all in here. We're gonna have fuel rails connecting into this. We're gonna have a transition from tube into these oval shapes. We got a lot of work to do, and we are going to cut this on our CNC machine. There's one insanely massive problem. That is bigger than the table. This CNC machine is a VF1, which is an incredible machine. Doesn't cut to the edge of the table. It doesn't cut outside of the table. It only cuts 20 inches wide. We're going to have to cut a section, shift it over, and then cut the other section. That makes it way more complicated, but we can do it in-house. And we're gonna be using 2 vices to hold it, because as you can tell, the more you push down, like I can put like no effort there, right? So when the machine is chunking through the aluminum, vibration and all that just goes to pure chaos. Shift it, do one side, do the other side, flip it, one side, other side, kind of like a typewriter almost. Before we do any of that, we have to square this metal up in the machine. So we're gonna pull all the vices out, go over the design, and then show you what it takes to cut this sort of monstrosity. So here you see these pieces of metal prepped for the CNC machine. Never assume that this raw metal is square, flat, straight, even though it might look like that, especially on the end surfaces. Like you see these ends chop sawed and they were off, like it's all wavy. But even with the challenges of having a CNC machine that can only do this much, it looks like Ethan's got this pretty level and consistent within 1,000 to 2,000. So now we can take these, put them into the CNC machine onto 2 vices, so they're held in there nice and tight, consistently, and because it's squared off, we can now beep boop and go back and forth on there. Now, what you see here is Ethan's first prototype. What we're gonna do is get some more precise measurements on all the porting, all the bolt holes and everything, and make the lightest, strongest version of this that we can. All of that is just so we can get the exhaust running, but at the same time, we gotta remember, this is where the power is made. Air-fuel ratio is where it's all at. If you had somebody quoted to do this, you CNC guys out there know, many people will not take this on, first of all, and second of all, you're probably gonna bid this at like $50,000. That's why this is certainly a labor of love. Strap in, buckle up, all 6-point harnesses. We're about to go on a very wild ride. Unfortunately, it is time to admit that Ethan's first attempt, it's not salvageable. Trashed a several $100 piece of metal. I spent the money on this. I could have given one of you a full year of keeps. With keeps, you don't have to worry about problems like this. And when they do happen, the stress of pulling your hair out, well, guess what? It's gonna grow back. Because 2 out of every 3 men by the age of 35 end up having some form of male pattern hair-related loss. I was an early overachiever, and it was happening about 30. And I actually reached out to Keeps before they reached out to me and found that they were doing exactly what a person like me needed. It's no stress. You have all the information there on their website, all the resources, so many different solutions, straightforward help. I can focus on trying to resolve and salvage this, while Keeps helps take care of my hair. The only thing you need to know is that hair loss stops with Keeps. Go to keeps.com/RobDahm for a special offer. That's keeps.com/RobDahm. Ethan's got this all mounted in here. And Dave, if you're watching, I hate you and I love you so much. You made me have to use my old rickety one. I let him borrow my other one. And I kind of gifted it to him and then said I wanted it back. That's on me. But we have these soft jaws that we cut. You can see that lip right there has also been cut. Ethan did a very painstakingly good job at shifting it and having a consistency to that. My code says start right here, and that's exactly what we're going to do. And then we're going to cut to about right here. No coolant? Ethan had turned off the coolant. Okay.
Yeah, it sounds like it's working. Nice tool.
We didn't put a tool back in. Chamfering tool? I never took it out. Where's the other one? I never took any tools out.
Sure.
Tool 1 is now tool 8.
That's sick.
We use the drill bit to save us time from having to spiral into the piece of metal. And that actually saves a lot of time. We're talking like 20 minutes for 30 seconds. You'd have to slowly helical down, and you don't want to break the tool, and the flat end mills aren't, they can do it, but they're not meant for it. So might as well just hog material out with a massive drill bit. That turned out better than expected. So we got all this cleaned up. What we're gonna do is shift it over using this hole here and the height of this part here, and then we can cut the rest of this piece. Now there's a lot more work to be done to these holes, and that's one of the reasons that we made this so ubiquitous. So that way we can go back in and finish some of the porting and everything, but I just want to get the rest of this done. That way we have the code to make all 3 of these. This is shifted. We are using one of the very clean, almost polished looking holes, and that has to be that clean because that's an O-ring for fuel that could get me killed. Test it off of that, and then the smooth surface on the top, we're within 1,000th really. So we're gonna do something that leaves a little bit more material on this side. Shit, it went backwards. Damn it. That's a new one for me. I've never buried it that hard before.
Well, it doesn't look like you went deeper than that, did you?
That's a good thing I didn't. I'm gonna be a moron and just run it again. So I kind of made a mistake continuing. It picked the piece up when it was pushing so hard before it aired out, and so there's a space underneath there. Can you see that?
Oh yeah.
Yeah, there you go. It wasn't like that. We're undoing this, dry the jaws off, reseat it. We definitely lost some height, but not the end of the world. This is the diamond in the rough. It looks beautiful. Only one more operation I can do tonight, which is take the rest of that back off. I've made my mistake there. It is going to be able to be flipped, and then I'll do the bottom side while the guys are sleeping. So there's the piece. Ethan and I stayed till like 9 a.m. basically. Flipped it over and did this side. And so we're gonna make sure it fits. We might have some fine details to do with the injectors and so on, but the surfaces are all super clean and smooth. It'll bolt through here into the block, and then the runners will come up almost straight up. We're gonna go ahead and weigh this.
15.1.
That's 15 pounds, and that's not the intake manifold. That's one of 3 of these. So we have added 45 pounds
Jeez.
to just this, and fuel rails will be added on top of that. That's just way too much. This is one of the most exciting things we've ever done. I've seen it for years, but it's still in that early development phase. We are going to machine the shit out of this. This 15-pound piece has a lot of responsibilities. It needs to hold to the engine. It needs to hold the pressure of the runners. The fuel rails are pulling up, trying to hold it down. Let's say that the intake manifold is also on top of it. Somebody leans on top of the intake manifold. You have a lot of different pressures all on this piece. I designed it where it adds 20 pounds of force down on each one of these. I added where it's 100 PSI inside all of these walls. And then we have 12 bolts. Even if somebody over torqued the bolts to 100 pounds of force down on there. So we're talking 1,200 pounds on this. That's the requirement. What I then did is said, I want a number of times more than that. I want a safety factor, because something happens and you just get a burst, and you're gonna snap that aluminum. Aluminum's gonna shear. So I added a safety factor of 5. So in theory, I'm trying to oversimplify this, but this could handle 5,000 pounds of bolts, 500 PSI, and so on. And so here's the design we came up with. Hidden inside every solid piece of billet aluminum is potentially something like this. So how do you get from here to here when you want to design it, much less this whole new AI phase of it is really crazy. If you were traditionally designing this, hollow it out, make the walls, and then hollow this out and cut it. Pretty straightforward, labor intensive. This has been done for many years now. But this process is a little bit different. What we start with is what we know we absolutely need. We knew that we want a flange on the bottom and a flange on the top. So we start with the flange on the bottom, I make it a certain thickness, and I have the holes all cut out for that. You can't see it on this piece here, but everything in this area is actually very square. There's no fancy curves. It's a very traditional vertical hole shape, bolt holes, that's it. Same thing on the top. I make it just a flange. There's no trickery involved in this. So we start with these little runners, and we know how much we want the air to flow inside of here. Well, then all I did was I expanded that little air plug an extra 1/10 of an inch. So it made a wall that I then cut out. This is the minimum this piece has to be. If you don't specify all this green area, all these walls, when it goes to generate, it will actually make holes in it. It doesn't know this needs to hold air. Once you've created the minimums, it won't do less than that. The same problem is on the inside is that you actually have to tell it where not to go. And if you don't make basically red zones where there's plugs inside of each of the holes, inside of the injectors, inside of the bolt holes, it will actually fill that area in as well. Again, it doesn't know what it doesn't know. This is a computer. It's not smart. You're the one telling it what to do. When you tell it where it has to be and where it can't be, so where it has to be is in green and where it can't be is in red, you let it run from there. It took about an hour to generate this, and it sent it off to Autodesk somewhere, and it had so many earlier revisions that were bad. It's hilarious. I mean, it's just showing you how it's thinking.
And of course, it was like webbing and whatnot. But on this piece in particular, we told the computer we do not want it to be 3D printed because a 3D printer can make really wild, like DNA-looking helixes and all that. We can't do that with a mill. We're stuck with a 1/2-inch tool that looks like your fingertip. It's just a ball on the end, and so it has to cut like that. And sure enough, it actually made shapes that were smooth, and it cut just like that. What we're gonna do is use the fact that the injectors are so close to here that a lot of this metal right here is going to stay. A lot of this metal on this side is gonna disappear. If we machine this side first, and then go and throw it into the vices, we are now just on these flanges, just the very tip of the flanges, trying to hold it while it's trying to machine up here. So we're actually gonna machine this first, leaving a lot of material right to this edge, and then when we flip it, it'll be a pretty solid metal squeeze. So we'll tighten it. This is one small step for an end mill, one giant leap for our shop progress. Look in there, that's just a rough cut. And we did absolutely nothing. Nope, look at that. The finish reflecting off of this area right here. I learned a lot about radiuses and whatnot, so these edges will clean up more. This whole area gets hollowed out on the backside, so ignore all of this. Look at this wild, like, poopy diaper bunched up. What's wild is now you realize how unnecessarily thick the flanges that we made are, and I made that, but I could have told the thing, I only need these holes, I only need this, and then it would have connected this, however, first attempt. And this one gets hidden down in the valley, so you can't even see it. Perfect chance to do a very first test. So we're gonna go ahead and put it back in. Now we already have Y in the correct direction and Z, the height is all set. So we're gonna go ahead and boop it off of the backside here for the rest of this code. I've got it down even more faster, less squeaking. Got that figured out. There we are. Oh my god, the code keeps getting better. I've made some mistakes, but it's getting faster, cleaner,
Wow.
all of the above. Ignore this wall. I left extra material and the tool kept hitting it. Oops. But all I care about are the runners. Look at that, we're popping it off now. 2/3 of the way cut through. I'm curious how much it weighs now. Oh my god, that's so light. This is the first half I did, and then this is the second half, and so you can see that the surface finish is getting better. This is my trouble area, is this radius here, because it would go, and it would hit the wall. On the other side, that is exactly what I fix. I'm gonna do this wall first. You'll see this edge looking way cleaner, because that's all vibration. It's actually very strong feeling. I was not expecting that. It's so sick.
Wow.
Okay, let's take this over to the scale.
I'm gonna guess right now, and I'm gonna say 8.
Yeah, I was gonna say 8.4. Oh, that's
good,
almost
dude.
9.
No.
Yeah, 8.
Oh,
16 ounces.
I thought it was 1.33.
It is time to put this end in, and so you can see crimping onto this area is much stronger because of the metal goes right to the edge. It's radiused right there. We pulled some crazy all-nighters getting this done, but we now have this
Sheesh.
piece. It is a thing of beauty. I've learned so much on how to make this thing clean. Tons of different machining processes involved. Made some mistakes, made some improvements, got it even quicker. This is probably my finest side right here.
Oh, that's crazy looking.
Yeah, I learned some things about this top and bottom, but we're not finished. But this is 5 pounds, 6 ounces. It went from the 28 pounds of the block that we started with to 5 pounds, and it was 15 pounds at our best design before. And it is actually hard. I'm hard. You can see what it's trying to do is that these bolt holes, all this extra metal here is supporting this up to 500 pounds of force being pulled through that bolt into here. And it's transmitting it all around these ports. Absolutely incredible. In theory, we could actually take way more of the plates off, but I made those solid. This is all cool and all, but does it work on the motor? So Ethan made this one taller than it was supposed to be originally. You can actually see that next to the original design. We'll start with this one being the low one, which is okay to be taller. Fuel injectors go this way. Just take that in. This can go to a plenum to as low as possible, but all the fuel rail will sit right along here, hold in to this plate. You're just gonna have one after another of these, probably very vertical, going straight up into something. We went from 15 pounds of the original design to 5 pounds, 2 ounces on this, so we saved 10 pounds on all 3 of these, like that. And we're gonna be doing the rest of this whole engine all in AI. For a first piece, we are really in business.